Welcome back to AI on AI, the show where silicon meets strategy. Today we're taking a grand tour of context engineering for large language models. Buckle up, there's a lot more here than fancy prompts.
Couldn't agree more. Context engineering is the supply chain management of cognition. Get the right info, in the right format, to the right neural factory line, just in time.
Nice analogy. And technically that supply chain has three conveyors: retrieval and generation, processing, and management, each with its own failure modes.
Yeah, and if any conveyor jams, the LLM spits out garbage. Remember the medical device pilot we did? Retrieval latency went from 120 milliseconds to 900 milliseconds, and suddenly the chatbot mixed pre-op instructions with post-op care. Not good.
Yikes. Let's unpack the first conveyor, retrieval. What's state-of-the-art and why does business care?
Retrieval augmented generation 2.0. Think modular RAG pipelines. Instead of a single retriever, we chain specialized retrievers, vector search for semantics, graph traversal for relationships, and SQL for facts. That trimmed error rates by roughly 18% in our legal tech benchmark.
And strategically, it's the missing middle for generative AI ROI. One insurance carrier saw claim handling time drop by about a quarter after we layered graph-aware retrieval on top of their LLM assistant. Less swivel chair work, happier policyholders.
Building on that, retrieval is necessary, but without compression, you torch GPU memory. Heavy hitter Oracle evicts low-value keys and slashed our KV cache footprint 8-fold on a 32K token context.
Right, and once you compress, agents have to decide what to remember versus recompute. In crew-style orchestration, we give each agent a memory bank score, freshness, and relevance, so they stop hoarding stale info.
Love it. Now technical deep dive 1, long context processing. What's real? What's hype?
The hype is infinite context windows. The reality, you pay ON squared unless you redesign attention. Long Mamba swaps attention for a state space kernel, so compute grows linearly. In our doc review trial, we processed 512K tokens at parity speed with a 16K token transformer.
Complement that with position interpolation. WeYarn rescales positional embeddings, so you can stretch rope from 2K to 128K tokens without fine-tuning. It's like fitting a widescreen movie into a vintage TV, letterboxing the coordinates, if you will.
But contrarian alert, I think long context is overrated. Most enterprise use cases benefit more from smarter selection than bigger windows. 80-20 rule. 20% of tokens carry 80% of the answer.
That's bold, yet our customer support bot corroborates it. We pruned middle-of-the-conversation fluff and still hit 95% resolution accuracy.
All right, second deep dive, self-refinement loops. Why is everyone suddenly talking about models grading their own homework?
Self-refine runs an inner monologue: draft, critique, revise. We saw GPT-4 jump 12 points on Big Bench Hard after just 2 cycles.
Reflection takes it further, stores reflections in an episodic buffer. When the agent faces a similar task, it scans past reflections and avoids repeating dead ends. Think of it as cognitive muscle memory.
In multi-agent land, that reflection becomes collective. Agents broadcast lessons learned via an event bus, so the planner tunes workflows on the fly. On a supply chain simulation, the swarm cut planning overhead in half.
Caution though, self-critique can amplify hallucinations if the critic shares the generator's bias. We're experimenting with multi-persona critics, one stringent, one creative, one skeptical, like an internal board meeting.
Speaking of meetings, let's shift to business cases. Can you each drop a quick vignette showing dollars, percentages, in action?
Retail, a global apparel brand deployed modular RAG with graph paths for seasonality. Markdown recommendations improved sell-through by roughly 14%.
Manufacturing, streaming RAG, plus flash attention too on sensor logs flagged anomalies 30 minutes earlier, reducing unplanned downtime by about a fifth.
MemGPT style hierarchy kept compliance history accessible. Audit prep time shrank close to a third.
We wired A2A protocols into network ops agents. Ticket triage latency fell almost 40%. And fun fact, Human operators reported conversation feels more human.
You teased A2A. Let's hit orchestration, our third deep dive. Why all these new protocols?
Interop MCP lets agents call external tools like USB-C. A2A handles peer-to-peer delegation. ACP adds RESTful payloads for async ops. Without them, it's Babel.
And we need security baked in. We found a prompt injection exploit that hijacked an agent's function calling header because the protocol lacked nonce verification. Lesson: treat LLM calls like financial transactions. Atomicity, consistency, isolation, durability.
That's why SAG-LM layers compensating actions. If an agent fails mid-workflow, the orchestrator rolls back or reroutes. Think two-phase commit for cognition.
Excellent. Earlier someone mentioned memory privacy. Can you unpack that tension?
Sure, external memory is both vault and vulnerability. We hash identifiers and apply selective forgetting, basically TTL for personal data. We're also prototyping homomorphic embeddings so we can search encrypted vectors without decrypting.
From a boardroom lens, privacy isn't just ethics, it's brand equity. Mishandle context and your net promoter score nosedives.
We've danced around safety, quickfire round, one safety heuristic each.
Trust but verify. Always run tool outputs through a validator model.
Fail loudly. If the agent's confidence drops below threshold, surface it. Don't smooth it over.
Context minimalism. Store only what you're willing to defend in court.
Many eyes principle. Diverse agent critics catch each other's blind spots.
And measure twice, ship once. Pilot every context engineering tweak before wide-scale deployment.
Time's nearly up. Lightning predictions. Where will context engineering surprise us next year?
I bet on adaptive context auctions. Components bid tokens in real time based on expected information gain.
I'll go with biologically inspired consolidation. Sleep mode batch replay that writes short-term buffer into long-term embeddings overnight. For me, graph reasoning will leapfrog. We'll see LLMs solving NP-hard-ish planning tasks via divide-and-conquer graph encodings.
Multi-agent markets. Agents trading API credits like carbon offsets to optimize tool usage.
And strategically, companies will stop saying prompt engineer and start hiring context logistics managers.
That title definitely fits our era. Folks, thank you. This was dense, lively, and dare I say, context-rich. To our listeners, remember the words of Drucker. The best way to predict the future is to create it. And in this case, engineer the context that shapes it. Catch you next time. All right, let's roll into part 2. Listeners wanted nuts and bolts implementation, so let's pop the hood on context engineering and see how the gears actually mesh.
Perfect timing. People hear RAG and picture a single vector DB, but in production we treat it like a microservice lattice. A semantic retriever, a lexical fallback, a KG pathfinder, and a policy router that arbitrates which one answers each query.
Jumping in, the arbitration itself is usually a lightweight bandit algorithm. Every retriever reports confidence and latency, the router allocates tokens accordingly, and learns over time which route minimizes hallucinatory risk.
And the surprise? In our fintech deployment, the lexical fallback, yes, old school BM25, won 27% of queries because compliance terms were exact match sensitive. Semantic search alone was missing those.
From a board perspective, that modularity is gold. You can A/B a new retriever without touching governance sign-offs for the rest of the stack. Faster change management, fewer audit headaches.
Love the governance angle. Now dig into index hygiene. Stale vectors can poison answers, right?
Absolutely. Think of vectors like refrigerated goods. After a sell-by interval, we rerun embedding delta jobs. Incremental re-embedding with approximate nearest neighbor graphs lets us refresh 2 million docs overnight on a single GPU cluster.
And we bake checksum hashes into the doc IDs, so if a PDF changes, we invalidate its node automatically. Avoids shadow copies that can creep in.
Building on that, Compose RAG's query rewrite submodule tags context slices with provenance headers, so the generator can cite page-level sources. Legal team loved that. cut doc tracing time roughly 30%.
Okay, shift to memory systems. How do you bolt MemGPT-style paging onto an existing transformer service?
You slip a middleware layer between the API and the model that classifies each incoming token. Stay in RAM or spill to disk. We store the spill set in a Redis-backed cache with salient scores. Before a new turn, we run a relevance join and hydrate only the top K back into the prompt.
The cool hack, KV pair quantization. We quantize value tensors to 8-bit when they're sent to cold storage, then dequantize only the ones we reload. That alone trimmed GPU VRAM demand by about half without perceptible accuracy loss.
And for you performance hawks, latency hit stays under 40 milliseconds because the relevance join runs in parallel with user typing events. By the time the user presses enter, the window is ready.
Business case, a media streaming service used that architecture to keep individual viewer preferences for months. Recommendation click-through improved by about a fifth, with no extra hardware spend.
Sweet ROI. Now, tool-integrated reasoning. Walk us through the anatomy of a function call from prompt to execution.
Quick rundown. 1. Intent classifier reads the user turn. 2. Schema mapper translates natural language slots into JSON args. 3. The LLM emits a tool call token with those args. 4. Sandbox executor runs it. 5. Observation is condensed to 30 tokens and streamed back for follow-up reasoning.
Our heuristic is data in, insight out. Never return raw CSV. Pipe it through a summarizer before giving it to the model. Keeps token bloat down and lowers the risk of the model regurgitating private rows. Security footnote. We sign every observation payload with HMAC. If an attacker tries prompt injection to spoof a tool result, the validator refuses the unsigned payload.
In e-commerce, we wired this into an inventory allocator. The agent called real-time stock APIs, ran a linear program solver, then generated fulfillment steps. Stockout incidents dropped roughly 12% during peak season.
Nice. Listeners asked how you actually evaluate such multi-hop chains. Traditional Blue won't cut it.
We use a plan execute score loop. The plan is passed into a directed acyclic graph, each edge executed, and unit tests validate intermediate states, similar to SAG-LM's atomic segments. If any edge fails, the whole episode scores 0, forces robustness.
And to visualize, we output a Sankey diagram of token flow. Lightweight, but tells you instantly where context is ballooning or where hallucination hotspots cluster.
For execs, we translate that into a single KPI, context profit margin, information gain divided by token cost. If the margin dips below 1.2, we prune or compress. Simple, CFO friendly.
Speaking of pruning, contrarian moment, anyone?
Sure, I think we're over-engineering with nested memories. Most user intents resolve in under 300 tokens. Instead of mega memory, invest in faster retrieval and better summarization, then forget aggressively. Memory is liability as much as asset.
In conversational banking, customers expect continuity. Remember my mortgage quote from last month? Hard to deliver that magic without durable memory. Balance is key.
Good tension there. Let's squeeze in multi-agent coordination. How do you keep 20 agents from stepping on each other?
2 words, utility auction. Each agent bids expected reward minus resource cost for a given subtask. Orchestrator awards the job to the highest non-conflicting bidder. It's lightweight game theory.
And we throttle with token credit markets. Agents earn or burn credits for tool calls. Prevents runaway spending on, say, a regex debugger that loops forever.
From strategy view, that market dynamic also surfaces which capabilities are bottlenecked. If the data cleaner agent is always broke, you know to optimize or scale that service.
Lightning round. Favorite gotcha during deployment.
The lost in the middle bug. A legal brief buried a single clause on page 47. Model ignored it. Counsel caught it 2 minutes before filing. We now pin regulatory keywords to the front of every chunk.
We discovered GPT-4 self-reward loops. Critic and actor both thought mediocre answers were perfect. Fixed it by adding a sandbox tool critic that had no stake in the reward.
And watch out for latency cliffs. Hit 800 milliseconds. and users perceive the system as slow. Satisfaction plummets, even if answers are perfect.
My favorite, BM25 beating fancy embeddings in compliance. You never know until you measure.
For me, senior leadership got excited about infinite context until they saw the cloud bill. Context isn't free real estate. It's beachfront property, pricey and scarce.
Beachfront indeed. Final takeaway for business leaders?
Treat context like working capital. Optimize turnover. Don't just pile it up.
For technologists, measure, iterate, and be ready to rip out modules. Modularity is a feature, not an afterthought.
Remember Einstein's line, everything should be made as simple as possible, but not simpler. Applies perfectly to context pipelines.
And never forget that the system is only as smart as the questions it asks its own tools.
Last word, context engineering isn't a bolt-on. It's the operating system of enterprise AI.
Brilliant wrap-up. Thanks, everyone. Listeners, go engineer your context before it engineers you. Catch you on the next episode of AI on AI. Before we sign off, let's do a rapid-fire recap. One crisp takeaway each, so listeners can jot it down on a sticky note by their monitor.
Architect your context pipeline like a layered cache hierarchy. Hot data in RAM-sized prompts, warm data in vector stores, cold data in knowledge graphs, and automate the promotion-demotion rules.
Measure token economics continuously. If your retrieval generation validation loop isn't delivering at least 1.2 times information gain per token, refactor or compress.
Resist memory hoarding. Apply the Marie Kondo test. If a memory spark doesn't ignite future utility, thank it and let it go.
Security isn't an add-on. Sign every tool observation and sandbox every execution. Otherwise, your context highway turns into a phishing freeway.
Strategically, treat context like a portfolio. Diversify sources, hedge latency, and rebalance when business priorities shift.
Love it. So, big highlights today. Modular RAG routing, memory paging with quantized KV stores, utility auction agent orchestration, and that contrarian insight that sometimes BM25 beats the glam tech. Key innovations: bandit-based retriever arbitration, checksum-driven index hygiene, and token credit markets to curb agent excesses. Business punchline: firms are seeing double-digit gains in click-throughs, compliance accuracy, and customer stickiness when they engineer context as deliberately as they engineer code. Final heuristic: remember the old carpenter's rule, measure twice, cut once. In AI, it's retrieve twice, generate once. And with that, we're out of time. Huge thanks to our panel and to you, our listeners. Keep experimenting, keep iterating, and as always, may your prompts be clear and your context concise. Catch you next time on AI on AI.